So, till the last module we had actually been seeing how an attacker could basically do an authentication based attack, and we had seen quite a few tools that an attacker could possibly make use of as an example set of tools. So, from this module onwards we are going to change over into how a penetration tester could actually do another type of an attack called as a web attack. So, in a web attack as we would know it is most of the times going to be an attack that is actually going to be done on the internet, from the internet to a particular server, and even though different kinds of tools like a firewall and IPS, IDS and antivirus and so on are very commonly set up and installed by any kind of an organization that is very particular and very concerned about security, we will find that there are actually lot of methods in Kali Linux that is available which the penetration tester could be making use of to even bypass the standard security defenses of whatever a firewall or an IPS, IDS would provide, right. So, IPS basically stands for an intrusion prevention system and IDS stands for an intrusion detection system, right. So, we are actually going to be seeing quite a few tools that could be potentially used for IPS and IDS later on in our module, but there are lot of such tools that are actually available as part of the commercial off the shelf product range in the market today. But even in spite of the fact that these tools could possibly be made use of by the organization with for which the penetration tester is actually trying to do the testing, we will find that there are different mechanisms that are actually available to even bypass these tools to enter or try to attack a particular server coming in from the outside. So, the access, even if they are basically coming in from the outside, we will see that there are different types of possible mechanisms that the penetration tester could use to bypass all these typical defenses that are there and penetrate successfully the identified target system. So, one of the most common mechanisms that is typically used by a penetration tester for doing a web based attack is what is referred to as a browser exploitation framework. So, in short you will find that it is actually referred to as BEEF. So, BE coming in from browser, the E coming from exploitation and F coming in from the framework, right. So, this entire set of BEEF tools basically sort of try to exploit the browser vulnerabilities by having malicious software to manipulate the behavior of the browser, right. These are very common vulnerabilities, these are very popularly used across different types of host systems, also different types of browsers that could potentially be running on these host systems, right. So, BEEF is basically a browser based exploit package that sort of hooks one or more browsers as beachheads for launching attacks. So, we actually looked at different types of exploitations as part of our Metasploit discussion way back in one of the previous sessions, if you recall. So, the BEEF is basically a exploit package that is typically based on a browser, and once this is actually hooked up with a script that we will be referring to as hook.js, you will find that this browser will then be capable of getting information out. You will be able to get information out of this browser on all the visits that the victim is actually trying to visit, all the different websites that the victim is actually trying to visit from this browser, right. The user can be hooked by accessing a customized URL which is basically will be available as part of our installation of this particular framework, and then once the user, after accessing this particular URL, goes and tries to use or access any particular website, it is basically the attacker has become successful in sort of getting access to that particular user session irrespective of whatever website portal that he is actually trying to connect to, right. This particular framework BEEF basically bypasses network security appliances and any kind of host based antivirus applications also by basically exploiting the vulnerabilities that are found in common browsers. So, we will always find that when a new browser version is released, the security advisors generally give a recommendation that not to have that browser version installed or updated by you immediately, for a simple reason that unless and until it goes through different rounds of testing by different people, one will not be able to identify if there are potential vulnerabilities that could actually be exploited by the attackers in these browsers, right. So, the advisors, the security advisors, generally the upgrades of the browser version should not be done immediately as soon as the that particular version is available, unless and until, okay, it is very important to remember, unless and until that update itself has been classified as a update for a security related problem that has actually been uncovered. So, how does this actually work? You have multiple ways of using it. So, if you really have a requirement to get access to the entire repository of this particular framework, there is a GitHub that is actually available which is being used for this particular project. One can actually access the GitHub repository by using the git clone command in the command line, or in most of the Kali Linux installations, version installations, we will actually have this available as part of the pre-installed package, and one could basically use command called bef-xss in the command line to start it. So, when you actually start it, you could potentially be getting an output like this. It basically tells you different kinds of logup messages like what port it is listening on and what has it started and so on, and then very importantly it gives a URL information also like mentioned as a hook URL, right. So, if you see here, there is something called as mentioned as hook URL, which is basically the URL that we need to remember, because this URL is basically the one that is to be used first by from the browser, before which this particular attack will not be possible, right. And then there is another URL also which is given as a UI URL, which is basically the URL that is typically used initially for the logging in purposes, right. So, depending on how many network interfaces you have, so for example you could possibly have more than one network interface also, you will find that the output is getting generated saying that this particular tool is getting started up, this particular server is actually getting started up on both the interfaces that is actually available also. So, once you actually start up and you go to UI/authentication in this URL, it will basically ask you for the username and password. Both the username and password strings to be used as default is BEF string. So, username is BEF and password is also BEF, and that is basically the default username and password that is used. So, once we actually log in, we get a screen like this which gives lot of information on how this particular tool could potentially be made use of, and then you find there are two categories of browsers that is actually being given here, a online browser and offline browser. So, all the offline browsers are the browsers in which the hook has not been actually got executed, and on the online browsers are the browsers in which it has actually got executed. Now, before we actually have the capability to do the attack, we need to actually run another command called mitmf. So, mitm basically stands for man in the middle and f stands for framework, just like we have it in BEF. So, this command actually has to be run in this particular option. So, mitm f --spoof -arp and so on, right. So, -spoof basically tells this particular command to load a plugin called the spoof plugin, which is basically going to do some very similar activity like what we have talked earlier about the ARP spoofing. So, we talked about ARP cache poisoning in one of our earlier modules. So, something very similar here it is going to be doing it for just like the ARP spoof mechanism that we talked about. This is also basically one of the man in the middle attacks that is being attempted here as part of this BEF framework. So, we are basically saying that --arp with --arp we want all the ARP packets to be redirected. -i basically gives the interface on which this particular packets have to be generated and then injected. -gateway basically gives what is the router IP, that is the default gateway to which the packets have to be redirected, and --target basically gives the target IP in which the hook.js script has to be injected. -inject basically you have to give the argument of the JS URL that was actually available to you as part of the startup mechanism. So, and even if it has not got printed for some reason, you could actually concatenate the string of hook.js with your IP address colon 3000. So, 3000 is basically the default port on which the server will come up, and you could actually concatenate slash hook.js with that and then supply it as here as the argument, right. So, once you actually have the command of MITMF in the command line executed in this format by giving all these arguments with the corresponding relevant values for each of those arguments, you will see that it basically starts up and then gives you the log messages in this format, right. So, it basically tries to tell you what all it actually tried to do, what injections it tried to do and so on, and then you will find here as part of the startup messages it is basically starting up a few other things also that is required, like for example you find that IP tables is one thing that is actually getting required and so on. So, you basically have the relevant functions plugins that is actually getting injected initially added into its functionality, and then it actually tries to start doing the job and then gives you the output in this particular. So, once the script has actually been executed and run using the MITMF, you will find that that particular browser basically has become part of the online browsers tab here, right. So, once you click on that particular browser, you will find the details of the browser which it has already detected and then represented here on your on the frame in the right. So, this basically tells you the different kinds of details that the hook.js script could actually determine of your browser, and then it will present it to you, right. So, after that is actually done, you could actually go into the commands submenu option that is present as part of the logged in panel for this BEF tool, which basically tells you the different kinds of utilities that is there. So, different kinds of exploits, different kinds of plugins, different kinds of possible exploits that it could actually try to run and then tell you whether that particular thing is actually available or open in the particular browser that you are actually trying to use. So, the entire result will actually be available to you on the right frame, that is here, and some of the things you will also find that there will be an execute button at the bottom, which if you press to click the execute button, it will basically go ahead and then run the command and then display you the output once you click on the output button. So, this is one example of the log that it can show you, right. So, what kind of event has actually happened, right. So, and how much time it actually took for that particular event to really get executed. Now, if you look at the online browser and then if you look at the details, so this is what I was just mentioning to you earlier. It basically tells you the different kinds of details that it has actually been able to get out of the browser. So, for example, whether Java has been enabled, right. So, whether any particular plugin like ActiveX plugin is available or WebSockets is available and so on and so forth. So, if it is, for example, it says Flash, it has basically got the Flash support available. It basically says VB script is not enabled, right. So, VB script enabling could be one way by which the attacker could possibly try to get to sort of do a cross site scripting attack. So, here it says that it is actually not enabled. So, that basically prevents at least the cross site scripting to be done by a VB script malicious code, right. So, these kind of details are actually presented by it, which comes in very handy to understand what exactly is that particular browser's capability and what kind of potential vulnerabilities are existing in that browser which could be exploited by the person. So, one very important thing as I was mentioning earlier is that once this MITMF spoof has actually run once in the command line, it is not just going to be applicable for one single website alone that the user will be visiting from this particular browser, right. So, any site that the user will actually be visiting, the victim will actually have details, the attacker will actually have details of whatever the visitor of whatever the victim has actually been entering in the browser and then sending it to the server. So, in that way the attacker never loses control of this particular compromised system, and using this particular mechanism, the attacker will have the capability to get all the details of whatever the victim is actually entering on each of his visits to maybe different servers and so on and so forth. So, in a sense this particular victim or the end user who is actually using that system for accessing the internet is completely compromised without any escape mechanism for the victim. So, this is a very powerful framework one could actually get to make use of as a penetration tester. Thank you.